Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CPAT, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in Computer Science. In the previous session, we had been seeing about the basic concept of the structures in C, the way a structure is declared and initialized. In today's session, we will be seeing about the use of structure with functions, how they are passed to functions, and the other concepts like the use of the type-def, bit fields and enumerated data types in C. So, today we will be seeing about array of structures, the use of structure and functions, and type-def statement, bit fields and the enumerated data type. So, we will go one by one, starting with the concept of array of structures. So, what is an array of structure? We have seen about structure within structure and nested structures. So, what is the difference between the two? Array of structures is nothing but a group of structures organized in the form of an array. We know what is an array. An array is nothing but a collection of variables of same data type. So, when you group structures in the form of an array, they all belong to the same data type of that structure. So, it is possible to group structures in an array. An example for that is you have the struct employee. So, employee here is a structure tag. The members of the structure, you have a string, you have an integer variable, you have another character variable, and you are having struct date DOB. So, here you are having both nested structures as well as an array of structures, because inside the struct employee you are having inside the structure employee you are having another structure date, and its variable name is given as DOB. Then you are closing the structure here, terminating it with a semicolon, and for this employee structure you are creating a variable which comprises of an array of 5 members. So, here if you see you are having 1, 2, 3, 4 members, the 4th member is the structure itself. So, you are allocating a maximum size of 5 to the array variable of the type structure of type employee. So, this is how you declare an array of structures in C. So, when you declare such an array of structures, you have to know how to access it. We have already seen how to access nested structures. So, the same concept is to be used here. Using the structure variable, you have to access the direct members of the structure using a dot operator. But to access the members of this structure date, you have to use this DOB variable. So, now let us see how we are going to access the members when it is declared as an array of structures. So, this is an example where you are having structure student. So, here student is the structure tag. You are having 2 members, one is of type integer, one of type string. You are closing the members of the structure, you are not having any variable over here. Okay. So, here if you see the structure is declared outside the main function. That means this becomes global in nature, this is accessible throughout the entire program. So, that is the first thing to be noted. Next you are having the main function, inside that you are having a variable I of type integer, and here you are initializing the values for the members of this structure. So, what are the values you are giving? Student S of 2. So, here is where you are having the structure variable being declared. Here if you see, you do not use the keyword struct at all, because the struct is defined globally. So, inside the main function also it will accept that the student is a variable of type struct or a tag of type struct. So, you just give student, you give the variable name and you are declaring it as an array which can hold a maximum of 0 and 1. So, 2 values, and you are initializing the values for the members of the structure. As I said, when you are initializing values this way, you ought to remember the order in which you have to initialize. First you are having an integer, then you are having a string. So, that is how the initialization is done here. First you are having integer value and a string, closing it within braces, separated by comma, then the second value. Again an integer, then a string, closing it within braces. Again the entire initialization you are closing within another set of braces, and you are terminating it with a semicolon. We are initializing this particular structure variable with 2 values. This is because this is an array variable whose size is given as 2. That means it will have 2 index values 0 and 1. So, this 11 and Anand is for the index 0, this 12 and Kumar is for the index 1. So, this is an array variable. So, we are initializing it with 2 values in one shot, and during initialization we have to make sure that the braces are balanced. You have a separate brace for each of the values, and the total initialization function also is enclosed within 2 braces, and it has to be terminated by a semicolon. So, now student S of 0 will hold the value 11 and Anand. Student S of 1 will hold the value 12 and Kumar. So, that is how the compiler understands this initialization. So, now we will see how it accesses these values. So, now we are going to print the details that we have entered. So, again we are using here a student report is a print display message. You are having a variable over here, you are having this loop initialization, I is equal to 0, I is less than 5, I plus plus. Now, here if you see I am giving I is less than 5, but I am actually having only 2 values for the variables, character as well as the integer for the student as well as the roll number. So, in such a case the compiler will simply print some garbage value. So, that is the point that is to be noted over here. Instead of giving an integer variable like this, we can have some mechanism where we identify whether the number of values in a structure is complete or not. And inside the for loop, what am I doing? I am printing the roll number S of I dot roll. That means first it will be S of 0 dot roll, next it will be S of 0 dot name. So, S of 0 dot roll will be 11, S of 0 dot name will be Anand. Again I increment the value of I, it will become 1. I will print S of 1 dot roll and S of 1 dot name. That means I will be printing 12 and Kumar. So, in such a situation, this is how we access the members of a structure. So, here the difference is not much. If it was not an array, we will just give S dot roll or S dot name. Because this is an array, we have to mention this extra information of the index S of I. So, here instead of using this for loop, you can simply give S of 0 dot roll, S of 0 dot name, S of 1 dot roll, S of 1 dot name. That is okay when we have just 2 or 3 or 4 values. But when you are using it in complex applications where you have around 100 values, it is always better to go in for a for loop, because it will just keep getting incremented and it will keep printing the values as such. So, here the important thing that you have to notice how to access. The only difference between a normal structure access and the array of structures access is the use of this index value, because using an index only you can identify the location of the value inside an array. And finally, the output is printed for the first one. Similarly, for the second one the output will be roll number 12 and name as Kumar. So, this is how an array of structures is defined, declared and accessed using structures in C. What is the use of this structure and functions? What are we going to do using functions and the concept of structure? A structure variable can be passed to a function either by value or by address. So, this is the same thing as a normal variable. We have already seen passing of arguments to a function, call by value and call by reference. So, the same way we can use a structure variable as well. And such a structure needs to be global in nature. We have already seen how to declare a structure to be global. When a structure is declared outside the main function, it automatically becomes a global structure. So, when you are going to pass a structure variable to a function, it is always better to declare it outside the main function. So, this is just an example for structures. Again, struct book. Book is a structure tag having 2 variables, one is string, one is integer. And here if you see, this is a new way of declaring the variable of a structure. So far we had been seeing only one way of declaring a variable. You are having a separate statement, having the keyword struct, having the name tag and having the variable name. So, here instead of writing a separate statement for declaring a variable, before you terminate the structure body with a semicolon, you are directly giving a variable over here. So, this is also understood by the compiler just the same way as you write a separate statement. So, this B1 will now be considered by the compiler as a variable of this type struct book, and then you are having the main functions. So, this is the way you declare a global structure in C. So, now we will see a simple program to pass the structure elements to a function. So, how we are going to pass structure elements? Now see, there are two ways of passing values to a function using structures. One is you can directly pass the address of the variable, or you can pass the individual values of the members. So this is an example where we will be passing the individual values of the members of the structure to a function. So first we have declared a structure. The structure tag is boy. It is having 3 variables, 2 of type integer, 1 of type string. No variables have been declared for the structure as yet, only the declaration of the body of the structure is given, and it is declared outside the main function, so it is global in nature. Next statement, here we are declaring the variables. Struct boy b1 is equal to, I am again giving 3 values. For the string I am giving the value Amit, for the age I am giving the value 25, and for the weight variable I am giving the value 50. So now this b1 structure variable is holding values for the 3 members of the structure. So how am I going to pass the values of this structure to another function? I said there are 2 ways. One is using the separate elements or using the address. So here we are going to pass these 3 values separately to another function. So this is the syntax for it. Print b1.name, b1.age and b1.weight. Always to access the members of the structure we have to use the structure variable and the dot operator. So b1 is a structure variable, dot name, dot age and dot weight. Here if you see, when we use the string, we do not have to mention that array each time. Only in the declaration of the body that array size is to be mentioned. Wherever else in the program we use the string, we are just going to mention the name of the string, that is it. And then here we close the main function. This is the declaration of the definition of the function that has been called. So print is the name of the function, these are the actual arguments. So they are being passed to the print function, this is the function definition. So this name will be copied to this S, age will be copied to this A, and WT will be copied to this W. So each of these values will be copied into these 3 arguments. So here what are we doing? It is a print statement, that means it is going to display some value. So here we are displaying the value printf S, D and D. S because it is a string, D and D format specifies because they are integers, and S and A and W. Return 0, we are just returning a null value and we are closing this function. So the ultimate output will be the values that have been initialized to the members of the array are passed to the print function and displayed inside this print function. So this is one way of passing the elements of a structure to a function. The next example we will see about how the address of a structure variable is passed to a function. So we are taking the same example of struct book. Book is the tag. Again we are having 2 variables, one is a string and one is an integer. They are declared outside the main function, so this is also global in nature. And again we are having a structure variable struct book b1, and I am again declaring 2 values, initializing 2 values. One is for the string, so name is holding the value Java and page is holding the value 880 for this variable b1. So how am I going to pass these values? If I am going to simply pass them by function, simply pass the elements separately, I am just going to use b1.name and b1.page, but here I am going to pass the address. That means here comes the concept of pointers. So the name of my function is show, SHOW, and the argument that I am passing is ampersand b1. That means the address of the structure variable b1. So this address is passed over here, the main function is closed. Now in the definition of this structure I am having a pointer variable. So the address of b1 is passed, which has to be copied to the variable. Because the address is passed over here, obviously the receiving variable should only be a pointer. Now we will see after the break how the address is copied here and how the variables are accessed. Now as we had been seeing the concept of passing the address of a structure variable to a pointer. So this is the syntax to pass the address. All the values for the members of the structure are contained in b1. So when we simply pass the address, it has to be collected by a pointer variable. That is why in the function definition we are having struct book pointer variable B2. So now this B2 will be holding the starting address of the value where the first value of the structure is stored. So when you are going to, we have already seen how to access the members of a structure using a pointer. We use the arrow operator. So that is how you are going to access the structure over here. B2 arrow mark name, B2 arrow mark page, and that is what is displayed here in the output. Java of 880 pages. Java is name, page is the value 880, and it is printed in this manner. Percentage S of percentage D pages. So instead of S, name is printed, instead of pages, page is printed. So these are the two ways of passing the arguments to a function. The first program we saw passing by value, and in this program we have seen passing by address. So this is the concept of using passing structure variables to functions. So with this, the general concept of structure usage is almost complete. We have seen the declaration and initialization of structures, nested structures, pointer structures, array of structures, and passing structure variables to functions. The remaining part of this session, we are going to see the general concepts of the use of type def, bitwise, and enumerated data type. See, they can be used in any situation. It is not necessarily that they are going to be used only with structures or any such particular concept in C. For any programming reasons, we can use the type def or bit fields or enumerated data type. As you know about these options available in C, you will be able to identify what are the situations where we can use these concepts. So first we will see the type def statement. Type def actually stands for type definition. Okay, that is, now so far we have been seeing about data types like integer, character, float, and double, or we have been seeing about user defined data types like structures or arrays, where the user itself defines of what data type a particular value should be. In arrays at least we have a single data type. Again the same concept of fundamental data types comes in. In structures, you create your own structure which can hold variables of the type that you want, that to different variables under a single name. So first we will see the type def statement. Type def actually stands for type definition. Okay, that is, now so far we have been seeing about data types like integer, character, float, and double, or we have been seeing about user defined data types like structures or arrays, where the user itself defines of what data type a particular value should be. In arrays at least we have a single data type. Again the same concept of fundamental data types comes in. In structures, you create your own structure which can hold variables of the type that you want, that to different variables under a single name. So this type definition is a slightly more advanced concept than that, where you give your own name for a data type. You are defining your own type. Okay. So this is used for creating a new data type. The syntax is type def. Type def is the keyword. Type is the data type which is already existing. The data name is the name you give to the existing data type. So we will see an example. Type is a fundamental data type, as I said, the user defined name. So type def is the keyword. Integer is the already existing data type. HOURS, hours, is the name you give for the data type int. And the next statement you are having hours HRS. So the compiler will understand that this HRS is of type integer. Why? Because already here in the previous statement you have mentioned that int hours and you have used the keyword type def. That means the compiler after it sees this statement, wherever in the program it sees this word hours, it will assume that it is integer. So if it sees a statement like this, hours HRS, it will assume that this hours is of type integer. So this is just a way to use your own name for a existing data type. So this is an example program. Here we are having the hash define statement h60. If you will remember, this is the way to define identifiers. So here h is an identifier and it is holding the value 60. So wherever in the program the compiler sees the alphabet capital H, it will assume that it holds the value 60, or instead of H 60 will be used. Then we have the main function. The first statement is typedef int hours, the same example I have used. So hours is now taken as the other name for integer. Next I am giving hours which will be considered by the compiler as integer hours. So this hours is now a variable of type int. Next I am giving printf enter hours, that is I want to get from the user how many hours is to be converted into minutes or seconds, and I am scanning it. Here I am using the %d format specifier because here it is of type int. And then I am simply printing the hours that I have entered in minutes and seconds. So there printf minutes %d hours into h. H wherever the compiler sees it will take it as 60. I wanted it to be case sensitive, that is why I have taken it as small h. So hash define small h 60 should be the right word that is to be used. So if you are using capital H over there, you use capital H over here. If you are using small h over there, you use small h over here. So wherever the compiler sees this h, it will take it as 60. So printf %d hours into 60, that will be converted into minutes, and when it wants to print in seconds, it will be hours into 60 into 60. So whatever number of hours you have entered, that will be converted into minutes and seconds, and that is what is printed as the output over here. So for 2 hours I am getting this value. So this is the concept of using typedef statement. Next we will see about bit fields. Bit fields provides the exact amount of bits required for storage of values. See, this you would have understood right from the beginning when we are using strings. So when we say character name of 30, definitely we may not be giving a name which is 30 characters long. Generally a name can be a maximum of say 10 or 15 characters if you are going to give 2 names. But when we are saying character name of 30, that is because we want to be safe that we do not run out of space. So to be on the safe side, we just assign the maximum value. So that invariably leads to loss of memory. So this bit fields is, instead of assigning storage in terms of bytes, 30 bytes, 2 bytes and 4 bytes, we are going to take the individual bits of a byte to store the values. 8 bits make a byte. So for an integer value, sometimes it is necessary even if there are 4 bits to store a value. But when we declare a variable to be of type integer, the compiler automatically assigns 16 bits for it. So though we are going to use only 4 bits or 3 bits, the compiler assigns 16 bits because the minimum storage allocation is 2 bytes. So the rest of the 12 bits are just wasted. So the bit fields tries to minimize that wastage. It calculates the number of bits required for a value of a variable, and it is specified as a non-negative integer followed by a colon. We will be seeing this in the example, how to declare the bit fields. It is used for conserving memory, and it is used for padding and alignment purposes. Padding and alignment purposes normally comes in situations where you need to have a minimum number of bits for calculation. So if your required value is less than the minimum required, you can simply add extra values which do not hold any particular value, but they are just used for making up that space. So this is the syntax. Here if you see, you are having structure vehicle, vehicle is the tag, you are having unsigned type, unsigned model, unsigned fuel, having a colon, and then you are having non-negative integers. What this indicates is that the first type can hold a maximum of 3 bits, that is the value required to specify it is only 3 bits. For a model you require only 2 bits, for a fuel you require only 2 bits. So what does this signify? This is the example. Now here actually you are trying to represent vehicle details. So if you want to know whether the vehicle is a petrol or diesel type, that is why this unsigned type is over here. You want to know whether it is a 2 or a 4-wheeler, and then you want to know whether it is an old or a new model. So you are having 3 categories over here, again you are having 3 categories over here. According to the user's discretion, if we just have 8 bits, it is enough to find out all these details. but actually if you go to declare it as you do usually using integers and characters, for petrol and diesel if you are going to assign character of 10, and for 2 or 4 wheeler character of 4, and for old and new model again character of 4, 10 plus 4 plus 4, that itself will take up 18 bytes. Okay, but actually according to our requirement we say that 8 bits itself is enough. So how is it possible? You try to minimize the number of characters by which you can represent the type or the fuel or the model. See, for the fuel you can just take the first 3 letters PET and DIE, or P and just D. So that will just require 1 or 2 bits for representation. Similarly for the type of the car, whether it is a 2 or a 4 wheeler, you can just have T and F, or TW and FW, 2 wheeler and 4 wheeler. So that again will take up only 2 bits. Similarly for old and new model, you can have OM and NM, OM for old model, NM for new model. That will again take up only 2 bits. So here you are trying to conserve the memory storage. Instead of simply saying character, type and assigning 15 bytes, character, fuel and assigning 10 bytes and making the maximum storage allocation, you can see the minimum way by which you can represent the information and you can conserve the memory for other purposes. So this is one option. Normally we generally do not use these bit fields in a normal programming, but just for you to know that this concept of bit fields is allowed in C, where if you are running short of memory you can always make use of this type to store the values. Now here if you see, no data type is mentioned at all. It is simply given unsigned, unsigned, unsigned. The number of bits alone is mentioned. This is because you mention the data type only for memory allocation purpose. Because if the compiler says integer, it will allocate 2, if it says character, it will allocate 1. When you yourself are mentioning the number of bits required for storage, the necessity to mention the data type is eliminated. That is why the data type is not mentioned over here. So this is the way we declare bit fields in the C programming language. There are certain disadvantages with bit fields. Array of bit fields is not permitted. We cannot use them with arrays, because an array holds a starting address of the memory location and it will simply keep moving by the number of bits according to the bytes according to the data type. So their array cannot keep looking out for what you have allocated and then keep moving up. Array is already defined to work a particular manner, so it will work only in that way. And pointers also cannot be used for addressing, because pointers also make use of the fundamental data type to hold the address of a variable. So both these concepts are not permitted with bit fields. The final thing that we are going to see today is this enumerated data type. Here we use the enum keyword to identify an enumerated data type. It is used to create enumeration types where programmer can create his own data type. See, in typedef statement we were making use of fundamental data types and creating programmer's own data type. Here we do not involve the concept of fundamental data type. The programmer creates his own data type according to the values that he is going to store. So that is the difference between the two. So here this defines what values the variables can hold, that is a user's discretion. The syntax is enum is the keyword, month is the name of the data type that is defined over here, enum, month and the values that it holds. Again the values that are being held should come between the opening and closing braces. It should be terminated by a semicolon. Now here the values which are present within the braces are called as identifiers. They should not be enclosed within quotes. So month is the data type that is being created, enum is the keyword for creation. The values that the data type can hold are present within braces terminated by semicolon. They are called as identifiers. They should not come between quotes. They should only be placed between braces. These are the rules to be followed. And here if you see, I am explicitly giving Jan is equal to 1. Now we will see why it is so in this final slide. Here you are having the main function, again enum month, I am having around 12 identifiers and I am printing f Jan is equal to %d Jan, December is equal to %d December, and I am getting the output as Jan is equal to 0 and December is equal to 11. This is because the identifiers are not taken as character values. Always in enum data type, the identifiers are taken as integer values by the compiler. and it invariably starts from 0, just like how the array indexes start from 0. If I explicitly want the value to start from something other than 0, then like in the previous slide I should give Jan is equal to 1 or Jan is equal to 5. In that case the compiler will start counting from 5. Because here I have not mentioned anything, it has taken it as default Jan is equal to 0. So that is the significance of such initialization, and this is how enumeration data types are used in the C programming language. So next we will see what are the possible questions that can come in this session. The use of enumerated data type to create the programmer's own type based on the values that it is going to hold. Bit fields save memory space because we ourselves, the user itself, defines how many bits are required for each value. So the user is only going to enter the values. So he is the best person to define how much of storage will be required. So instead of just allocating maximum storage, we can allocate the minimum required storage and save the space. Restrictions is we cannot use them with arrays as well as with pointers. Typedef is to create the user's own data type from fundamental data types. Passing structure elements, the normal way of passing variables using pass by address and pass by value, where to pass by the address you use the dot operator. When you pass by value you use the dot operator, and pass by address you use pointers and then use the arrow mark to access the values. So these are the concepts that we have seen today. With structures we have seen arrays and functions, and the other way of defining data types we have seen typedef and enumerated data type, and bit fields are nothing but conserving memory space and for padding and alignment purposes. We have seen example programs covering each feature. So with this we complete the concept of structures and the basic concepts for defining new data types in C. We will see about unions in the next session. Thank you.